Hi, and welcome to the Notepad Show. In today's episode, we are going to be rendering aggregate volumes in Renderman, clouds. Let's get started. So before we start with the scene and showing you how the scene is set up, probably should tell you what an aggregate volume is. An aggregate volume is a workflow where many individual volumes can be rendered in a scene, and Renderman will not see those multiple volumes with a boundary if they're like overlapping and intersecting. It just doesn't see them having a boundary, and it allows for much more efficient rendering. The other part of aggregate volumes that's important is that you can have multiple sets. So you can have a global aggregate set, and then you can also have, let's say, like an interior aggregate set. We're going to go over interior aggregate workflows in the next episode. For now, we're just sticking with global aggregate workflow with clouds. Okay? So, by the way, I will put a link to all the settings that we're going to be talking about and all the different parameters that are in this workflow. I'm going to be putting a link in the description for this document page. Okay, so here we have a scene. I'm loading in a cloud. It's a VDB. It's the Disney cloud. I will also have a link to where you can get this asset. And I have a density modifier attached to it. I'm lowering the density a little bit. I have a camera, and I have two lights. We're going to work with the HDR light first, and then I'll show you the PXR ENV light. So I'm going to delete the ROP here and start from scratch. So you would create a ROP, and you have this scene. There is a volume shader attached. We're going to go into this in a little bit. And if I hit render right now, it's not going to look great. The volume's not going to look very nice. And the reason it doesn't is because there are not enough bounces in the scene to allow light to bounce within the volume and light the volume from the inside. So we're going to stop the IPR. We're going to increase the bounces. Now there are two schools of thought here. You can do brute force, where we really increase the bounces. Now I'm going to do this, and you're going to see that it's not going to change. The rendering's not changing, but I put more bounces in. Why? Well, that's because this setting works in tandem with another setting that's at the ROP. So I'm going to copy this parameter. We're going to go to the ROP, and it works in conjunction with max diffuse depth. Your DCC might have it in a different place. I copied it as a relative reference, but now when I render, we get a nice render. Now this looks great, and this might be the way that you want to render. Know that this is an expensive way to render a volume. And luckily Pixar gives us a mechanism to make it more efficient. That's called MS approximation, multiscatter approximation. So that allows us to lower the number of bounces and mimic a higher bounce count in other ways, and I'll be showing you that in a little bit here. So why don't we stop the render? I'm going to lower the setting to 64 bounces. I found that to be the most optimum for this particular shot. We're going to go to the volume shader. Let's go over a little bit of the settings here. First things first, you have to put in the density attribute into the density float primvar parameter. and it will most likely be called density. And that comes from this VDB. Okay. I'm also, like I said, I'm controlling the density right here by half with a simple wrangle and a simple line of code. You could also add a spare parameter, which you should, and you could have controlled the density multiplier here. The downside with doing it that way is you have to restart the IPR every time you readjust this setting. It can't be adjusted while an IPR is going, which sort of makes it more difficult to do look dev when it comes to density, which is a heavy influence on the look of a cloud. So instead, I found a workaround by just using this F density attribute. Okay? Great. So with that said, let's look at other settings in the PXR volume. Diffuse color, emit color. These are used in PXR volume, but they're more used and change more often, definitely when it comes to fire and smoke. In the case of clouds, you really don't want to change these settings. I mean, you can do whatever you want, but they become much more global settings, especially diffuse color. And that has a pretty heavy influence on the overall color of a cloud. But again, if you're going for realism, you might want to keep these settings where they're at. If you're going for something more alien or unique or stylized, certainly you could adjust this setting. Anisotropy. Anisotropy setting, this setting here, controls how light bounces within the volume. So once light comes into the volume, what direction does the light bounce in the volume? When it's set to a positive, because by default it's at 0, which means it bounces randomly 360 degrees with no influence. The light just bounces everywhere. If you put it in a positive, that puts it in what's called a forward scatter mode, so to speak. And light propagates through the cloud in a direction that is with the light. So forward scattering from the lights, from a light's perspective. In this case, the brightest part of the HDR is a big influencer here. If you go to the negative, it's backward scatter. So as light enters the volume, it will bounce in the opposite direction, backwards, back towards the light source. And you might want a little bit of backwards scattering for look. It really all depends on what look you're after. And then this last parameter allows you to average out these two settings. So more towards 0 influences more the primary anisotropy, and going to 1 influences the secondary backwards anisotropy. If you leave it at 0.5, it's an equal average of both these settings. So I'm going to leave it at 0, so it only influences primary anisotropy. And here I'm going to put it to 0. And we're going to leave it at this setting right here because that's the look I'm going after with this HDR and this tutorial. Settings that don't get touched because they're old settings and they're related to the non-aggregate workflow that I mentioned earlier. That's an old workflow. We are only working in an aggregate workflow, but in a non-aggregate workflow, these are holdover settings. Multiscatter, multiple scattering and multi-scatter optimization. Both these would be checked off. But in our workflow, which is the newer workflow, these settings have been changed over to the light source. So you would make these changes at the light. In this case, this dome light. And they're done right here in this tab. This is where you make changes for multi-scatter approximation. What is multi-scatter approximation? Very simply, it allows you to lower the number of indirect bounces, so you're not doing brute force, and you're mimicking light bounces within the cloud. And it's just an optimization. Literally, it allows you to render the clouds at a very similar quality and a very similar look, but at a much more efficient way. And they are meant, the number of bounces and the MS approximate are meant to be worked together. Okay, so let's get a render going. And we got a nice render going. Now we've talked about MS approximate, but we're going to talk about the actual settings now. The top setting, 0 turns off MS approximate, 1 turns it on. There is no middle ground. You do not put the slider in the middle. It's either on or off. I wonder if Pixar will change that to a checkbox at some point in the future. The second parameter is bleed. This is how deep light penetrates into the volume. If we start the IPR again, and we lower the setting, we are preventing the light from bouncing inside the volume very far. If we go higher, much better, I don't want to say better, but much higher penetration in the volume. We're going to keep it at 36.36. There we go. MS approximate contribution is once the light has propagated and penetrated the volume, this setting tells how bright the light should influence that penetration. Higher value, brighter influence. It'll blow out the cloud. I haven't increased the penetration distance, but I've increased the penetration intensity. Okay. All right. So that is the bleed and the contribution. And one of the things you can do with bleed is this is where you can influence the color of the penetration of the light penetrating. You can influence how it looks, how the color looks. Slightly. You want to be really careful with the setting. But I could go in here. I'll go to extreme because it's always just easier to go to extremes. But this is where like you would add moisture to a cloud. And if you want a really weird looking moisture, like a yellow moisture or a red moisture, you can do so. But that's what it's for. And you have to be really careful because the slightest changes here have big consequences. So just be aware of that these sliders become very sensitive. Okay. All right. Now for a little bit of a surprise. There's other things that can influence the color or look of a cloud that sometimes get overlooked, and that is the ground. What's below the cloud? If I turn this off, look what happens. We don't have any bouncing from the ground up to the bottom of the cloud here. Now we can go to extremes here. If I go to the ground shader, look how much influence there is. So this could be like a desert kind of a scene. Or a forest. Maybe, again, you have to be really careful. You have to do your look depth. That's a little bit too much. That'd be more like it, maybe. Maybe even less so. See how little I'm changing the settings? We're going to go back to bluish gray. I picked that because I think that this HDR was shot in an ocean, so I just, made a bluish gray matte material to sort of mimic that. Okay. So yeah, a ground plane or geometry that's below the cloud can influence its color. All right, I'm going to stop the IPR, and I'm going to show you the Pixar daylight version of this scene. So I'm simply going to turn off. I have some MS approximate settings already set up, and I'm just going to hit render. Now I remember I could show you some influencing of anisotropy by, if I bring this towards 0, remember it makes it more what's called an isotropic kind of a volume. That means light, when it enters the volume, will bounce in any number of directions, 360 degrees everywhere. At random, there's no influence. It goes everywhere, every direction. So as I bring this more towards 0, you see how much influence there is. The light is it's not bouncing. Remember, there's a sun right behind this cloud that's right at the camera. So we are not seeing the light penetrate and bounce through the cloud towards us as much. If you go too much, well, you'll get into this kind of a scenario. And again, I played with the MS bleed and contribution to get this look. This is the look I was after. And now I'll show you what the final renders look like. So this is what they look like, the final renders. Clouds are expensive to render, so that's why I'm showing you final results. These were put through the ML denoiser. Okay. And that's about it. That's cloud rendering. It is the one workflow where there it seems to me that there's a lot more influences to the look of a cloud than any other geometry that I've experienced in Renderman. You got ground plane that can influence the color of a cloud. The actual light, which I didn't really show, but it's pretty obvious. You can certainly influence the color of the cloud when you change the light color. The overall global, which I told you, unless you're doing some sci-fi, you wouldn't change. But this can influence a cloud. Anisotropy can influence the color of a cloud, look of a cloud. There are a lot of variables. And it's fun. It really is. It's like putting a puzzle together, taking all the pieces and putting it together to get that look that you're after. And it takes a little bit of practice, but it's really, really cool. And I hope that this video helped you with your cloud designs. So thanks for watching, and stay tuned for the next episode. Have a great week.